Simple Harmonic Motion (SHM) is a special type of periodic motion where the restoring force on the object is directly proportional to the magnitude of the object's displacement from its mean position and x towards the mean position of the object. Or to put it simply, SHM is an oscillatory motion which obeys Hooke's law. Now, what is Hooke's law? Hooke's law states that the deforming force is directly proportional to the change in the length of the body to its original length within the elastic limit of the body. More on Hooke's law later. Consider an oscillatory system in which a mass is attached to the spring placed horizontally on a frictionless table. When the spring is compressed towards the position A, the displacement of the body is x from its mean position and the force applied by the spring on mass is F. The relation between F and x, the displacement, is given by Hooke's law. That is, F is equal to minus kx, which states that force applied on the mass is directly proportional to the displacement of the body about its mean position. The minus sign indicates that force is towards the mean position or opposite to the displacement of the body. Now, when the body is left on its own, a force acts on it which pulls the body back to its equilibrium position. This force is known as restoring force as it restores the body to its equilibrium position. As it reaches its equilibrium position, the body gains kinetic energy and loses potential energy, such that it gains velocity which is maximum at its equilibrium position, while the acceleration is zero. Because according to Hooke's law, acceleration is directly proportional to the displacement of the body. And as at equilibrium position, the displacement is zero, so the acceleration becomes zero. Now due to inertia, as the body moves towards equilibrium position, it does not stop at the equilibrium position. It continues to move forward or be compressed till it reaches the extreme position, point B. Now at this point, as the body moves towards the extreme position, point B, it loses its velocity, the velocity decreases to zero, and acceleration becomes maximum. Now this is again according to the Hooke's law. Now in terms of potential energy and kinetic energy, at any given moment, the total energy of this oscillatory system is given by the sum of potential energy and kinetic energy. Now during this to and fro motion of an oscillatory system, the total energy at any moment of time is given by the sum of potential energy and kinetic energy, where potential energy is given by 1 over 2 kx square, half of the spring constant, into the square of the displacement of the body, and the kinetic energy is given by half of the mass into the square of the velocity. Now as stated earlier, as the body reaches its equilibrium position, it only has kinetic energy, because according to the formula, kinetic energy is the product of the half of the mass into the square of the velocity, and it has maximum velocity as it reaches its equilibrium position. Now as the body moves towards its other extreme, point B, it only has potential energy because its velocity is zero and the displacement is maximum, and as potential energy is given by half of the spring constant into square of the displacement, so maximum displacement means maximum potential energy, and no velocity means no kinetic energy. To summarize, we can say that the total energy of the system is only kinetic energy when it is at equilibrium position as velocity is maximum, but it's only potential energy when the body is at extreme position where the displacement is maximum. Recapping. Simple harmonic motion (SHM) is a periodic vibratory motion in which any body moves to and fro about its mean position, in which there is a smooth transition between the kinetic energy and the potential energy at any given moment of time. There are other quantities such as time period, frequency, amplitude, and the angular velocity related to SHM. More about them in the coming videos. Stay tuned for more. Smartitute. Learn fast, adapt well.